Okay, so we're going to start going over the topic 3 review, which is the geometry and trigonometry unit. So this really should all be complete review as far as the material from geometry and pre-cal. Doesn't go near as in depth, especially into the trig, as we did in pre-calculus, so that's one benefit. However, there are a lot of shapes and stuff that uh, you know you may not have as much experience with. That takes a little bit of practice before you can really uh, figure out how to apply the geometry and trig that you actually know. All right, so we'll start pretty basic here. All right, so it says the height of a vertical cliff is 450 meters. The angle of elevation from a ship to the top of the cliff is 23 degrees. The ship is X meters from the bottom of the cliff. All right, so first it says to draw a diagram. So we have a cliff. Yay, cliff. All right, we have the ocean that's out here. All right, it says that the cliff is 450 meters. So this is 450 meters. All right, there's some ship out here. Yay, ship. All right, and we have the angle of elevation here, which that was god awful. In fact, I'm going to cheat. And we'll just make shapes. All right, so we now have a cliff that is 450 meters high. All right, my boat is over here. All right, and it says that the angle of elevation, so from here to here, is 23 degrees. And it says that the ship is X meters from the bottom of the cliff. So this is X. All right, and part B, so this is all we need for the diagram. All right, and calculate the value of X. All right, well, it says this is a vertical cliff, right? So we know that this is a right angle. So we can go ahead and use SOHCAHTOA here. Right? Do be mindful, depending on how long it's been since you've taken pre-cal, right, that SOHCAHTOA and the Pythagorean theorem can only be used for right triangles. All right. Also, law of sines and law of cosines can be used for any triangle. All right. So if you're ever in doubt whether a triangle is right or not, all right, then just use law of sines and law of cosines. You can never go wrong that way. And the law of sines and law of cosines are both in your formula book, if I'm not mistaken. All right. So, but here this is a right triangle, so we can go ahead and use SOHCAHTOA. So from my angle here of 23 degrees, all right, 450 meters, all right, the side that I know is my opposite side. The X, the side that I don't know, is my adjacent side. So from SOHCAHTOA, that tells us that we should be using tangent, right? So the tangent of 23 degrees is equal to the opposite over the adjacent. All right, so of course from here, you would have to multiply both sides by x to get it out of the denominator, all right, and then divide both sides by the tangent of 23. So x is equal to 450 divided by the tangent of 23 degrees. All right, we go ahead and pull out our handy dandy calculator here. All right, we do need to be careful that we're in degree mode. All right, guys, another big thing, of course, we'll go over all of these minor details before your paper 1 and paper 2, but for this course, you never need radian measure. All right. However, when they give you a calculator for the IB paper 1 and paper 2, it's going to be a cleared calculator, or if you use your own, they're going to clear it first. Okay. So if that happens, in default mode, your calculator is always in radian mode. Okay, so before the IB tests at the end of the year, one of the first things that you're going to do all right, is you're going to change your mode to degree mode, right? And also, like I said, we'll get to this closer to the test, but you'll also turn your diagnostics on to help us find our correlation coefficient, okay? So, but do make sure we're in degree mode here. All IB, for this IB course anyway, is degree mode. So we go out here, we just go ahead and do our 450. All right, over the tangent of 23 degrees. All right, and that gives us 1060, 133,565. Now, be very careful, all right? In IB, again, they accept two things. They accept exact answers, all right, and they consider whatever your calculator gives you, even though your calculator is rounding this to 6 decimal places, all right? They consider whatever your calculator gives you an exact answer, or to 3 sig figs, all right? Don't try to get cute and do some other random rounding, all right? Always do what IB wants, okay? So to 3 sig figs, you could just say 1060. Whoa, don't want that. All right, we could just say 1060. All right, or like I said, they accept exact answers, so you could write this entire thing, and they will accept that as well, okay? All right, number 2. Right? So in the diagram, triangle ABC is isosceles, right? AB is equal to AC, and CB is equal to 15 centimeters, and angle ACB is 23 degrees, right? So they have all of this on the diagram for you. They have these two sides marked congruent, and they have our angle given to us with the given side on here as well, right? So it says, find the size of angle CAB. Right now, we aren't really used to calling angles this way, right? We typically just would call it angle A, all right? But what they're saying is you start at C, then you go to A, then you end at B. So when they call an angle like this, they're really talking about angle A. All right, so do be mindful of that. So first it wants us to find the size of angle A. Now, right, with the information that's just on here, all right, we technically can't find it yet, all right, but what does this isosceles triangle tell us? The sides are the same. What else do we know about isosceles triangles, specifically with base angles? Yes, angle B will be the same as C. Our base angles are congruent, all right? So we can then say, okay, well, this has to be 23 degrees. Well, now finding angle A is very easy, right? Of course, all of our angles in a triangle add to 180. 23 and 23 is 46. 180 minus 46 is going to be 134 degrees. All right, so now it wants us to find the length of AB. All right, well, this is not a right triangle. All right, so please, 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 again, all right, do not ever try to use SOHCAHTOA or Pythagorean theorem or anything like that. All right, with an oblique triangle. What do we have to use with oblique triangles? Yeah, law of sines or law of cosines, right? Okay. And of course, those are both in the IB formula book that's given to you, so you don't have to memorize them, although anyone who's taken my pre-calculus class, which is all of you, should absolutely have them memorized. All right, we kind of hammered that pretty hard. All right, so law of sines, of course, is sine of angle A over side A is equal to sine of angle B over side B, which is equal to sine of angle C over side C. Now, with you IB students, I don't expect to have to tell you this, but I'm going to remind you again anyway. All right, every year in my pre-calculus class, every semester rather, all right, multiple students try to be like, set up some super equation where they have all 3 of these going on at once, okay? No, all right, we only are using any 2 of these at a time, right? This isn't some mega super equation where we're having like, 3 things going on at once. You either do sine of A over A equals sine of B over B, or sine of A over A equals sine of C over C, or sine of B over B equals sine of C over C, right? So you're just using any two of these at a time, all right? Now you have to use the one where you have both the side and the angle of any given letter, right? All right, so we just found angle A up here. All right, we have angle A and side A. That tells us we have to use sine of A over A, right? So I'm going to do sine of 134, all right, over 15. All right, now also, all right, we're going to, and really it doesn't matter. It tells us to find the length of AB, but AB is also congruent to AC, so it doesn't matter which one of these we find. All right, but we're just going to set that equal to, and also, guys, do be mindful that side AB, like we actually in pre-calculus called that little c, right? How we always did the kind of opposite sides. All right, so do keep that in mind. It's just another thing of how IB kind of notation and terminology differs from ours a little bit. All right, but here we'll say that that is equal to the sine of 23 degrees over, and we'll just use IB's terminology here, side AB. All right, so here we just go ahead and cross multiply, and then we're going to end up dividing by the sine of 134. So AB is going to equal 15 times the sine of 23 degrees, all right, over the sine of 134 degrees. So we go ahead and plug that into our handy dandy calculator. All right, so we have 15 sine 23 over sine of 134. All right, we do that and we get that side AB is equal to, again, we either want to give exact, like every single thing that's on here, or to 3 sig figs. I'm lazy, so I'll do 3 sig figs, 8.15. All right, and that would be centimeters. And again, IB is kind of weird about some things sometimes. A lot of times they ask these questions so that you don't have to include the unit of measure, right? A lot of times they'll ask, how many centimeters is length AB? If they phrase the question like that, then you don't have to write centimeters, all right? But if they just ask the length of AB, you actually have to write centimeters because without the centimeters there, who knows what 8.15 means, okay? So kind of IB's kind of a stickler about some weird things that. Okay, so the gradients of several lines are as follows. All right, so they give us lines A through H, and then they give us their gradients. All right, now gradient again is a weird IB terminology that you never see anywhere else in American education. All right, all the gradient is the slope. Right? They don't like the word slope. They call it gradient, whatever. Same thing. Okay, so it says find two pairs of lines that are parallel to each other. All right. Well, in order for lines to be parallel, they have to have the same slope. All right. So which slopes are exactly the same? All right. Well, the first one that popped out to me here was D and E. All right. So D and E is one pair, right? Because 3 over 6 is the same thing as 0.5. All right. And B and G. All right. So B and G. All right. Because it doesn't matter whether, like, where the negative is, right? A negative over a positive is a negative, and a positive over a negative is a negative. All right. So these are going to be the same regardless. Everybody, I hope, is good on those, right? This is like the easiest question that we could ever hope for on any IB assessment. Right. All right. So I'll make sure that you get nothing anywhere close to this on the test. I'll make sure that, especially Kristen. Kristen gets a special test. Remember, her test will be like every question that is just asked funny and is given weird and that is doesn't make any sense. Right. Yeah. Absolutely. We'll make sure Kristen gets that one. All right. So find any two pairs of lines that are right angles to each other. All right. So right angles to each other. That just means perpendicular. All right. So in order to be perpendicular slopes, all right, in order to be perpendicular lines, rather, all right, their slopes have to be opposite reciprocals. All right. And I say that because that's how we learn it in algebra and algebra 2, correct? Right. We always talk about opposite reciprocals. All right. However, IB is really weird about that as well. All right. If you are, if they ever ask you to show that two lines are um, perpendicular to each other or are at right angles to each other, if you say that their slopes are opposite reciprocals, which is 100 accurate and true in my opinion, right? They don't accept that. Right? They will only accept that the product of their slopes is equal to -1, which only occurs if they're opposite reciprocals. So I don't know what their hangup is about that, but that is something that you have to be kind of aware of. All right, so very weird, another weird IB thing, but it is what it is. So, right, all we have to do is find opposite reciprocal slopes. All right. So let's see what we can find here. All right. G and H would be, right, because 2/5 is 0.4, right? So that one would work perfectly fine. I guess you could kind of cheat, and since B is the same thing as G, you could say B and H. Or is that the only two even? Nope. Yeah, A and C would be as well, right? It'd be mean of them if they only had these two as possibilities. And that should be good. Yep, I think those are the only ones. What's that? Well, because B is the same as G, right? So if G and H are opposite reciprocals, then B and H have to be as well. Does that make sense? Right, since they're the same. That's why I kind of said this was kind of cheating, because it's really using the same. Does that make sense? Okay. Any questions or concerns there? Hopefully not. That's like, right, super algebra 1 stuff. All right, now this problem is massive, and I don't know if I'll be able to fit everything on the screen, but we're going to give it a shot. Okay, so the line L1, and I guess I'll give myself as much room as possible here. The line L1, shown on the set of axes below, has equation 3x plus 4y equal to 24. L1 cuts the x-axis at A and cuts the y-axis at B. When they say cuts, obviously, we just call that intersect, right? So hopefully that was obvious, but in case it wasn't, we definitely want to point that out. Okay, so write down the coordinates of A and B. Okay, well, A is the x intercept, right, of L1, and B is the y-intercept of L1, okay? So to find an x-intercept, you plug 0 in for y. So you just say 3x plus 4 times 0 is equal to 24, right? And we divide both sides by 4 here, and we get x is equal to 8, right? So that tells us that point A is 8, 0. right? Because I plugged 0 in for y, and I got 8 for x, right? Now, similarly, all right, to find a y-intercept, you plug 0 in for x. So we say 3 times 0 plus 4y equals 24. Of course, that just becomes 0, just as that did. We divide both sides by 4 here, and y equals 6. So point B is 0, 6. Awesome. All right. Part B, write down the coordinates of M, and it says M is the midpoint of the line segment AB. All right, so the midpoint is simply the average of the x coordinates and the average of the y coordinates. All right, I believe that formula is in your formula book somewhere as well. I think that might be in the prior knowledge section. So if it's not necessarily in this unit or in this topic specifically, you can always go ahead and look back at the prior knowledge. All right, so here we will have M is equal to the average of the x's is 4, right? 8 plus 0 divided by 2. And the average of the y's is 3. Good times? Okay. Great times. That's what I like to hear. All right, so the line L2 passes through the point M and the point C, which they tell us is 0, -2. Write down the equation of L2. All right, so first we're going to need the slope. All right, so the slope, of course, is y2 minus y1. So I'll say -2 minus 3 over x2 minus x1. All right, so in this case, that is -5 over 4, or -4, which is just 5/4. Okay, now oftentimes, all right, they specify the form in which they want the line. All right, so they'll say, give us the line in y equals mx plus c. Right? And IB does that as well, which is really weird. Okay, they don't do y equals mx plus b, right? They do y equals mx plus c. It's fine, no big deal, works the exact same way. M is still your slope, c is your y-intercept, all right? Sometimes they will also, in fact, more often than not, they actually request that you write it in standard form. So they'll say ax plus by equals c, or sometimes they even do ax plus by plus c equals 0. All right. So whichever way, just do it in that way. When they don't specify, you can give it in absolutely any form that you want. All right. So here I'm just going to write it as y equals mx plus b. So y is equal to 5/4 x. And 0, -2, right? Anything with 0, y is the y coordinate. So you can just put -2 here. All right, now, just as a side note, if they do ask for it in standard form or some variant of standard form, they always will tell you that they want integer coefficients. All right, so after you manipulated these around, like in order to get rid of this fraction, you would have to multiply everything by 4. Does that make sense? So in standard form, this would be like -5x plus 4y is equal to -8. Okay, part D, find the length of MC. Okay, so we have the coordinates of M. They tell us the coordinates of C here. All right, the length, we can use the distance formula, which the distance formula is y2 minus y1 quantity squared plus x2 minus x1 quantity squared. All right, so when we do that, all right, D is equal to, and we actually did y2 minus y1 up here, so that would just be -5 squared. All right, plus, and x2 minus x1 was what we did down here. So that would be -4 squared. All right, 25 plus 16 is 41. So this would simply be the square root of 41. Right? And there's no units that you have to worry about there. They don't give us any units, so we won't have to do that. All right, and finally AC. All right, well, A we have here is 8, 0, and C we have up here. So we do the same thing. So the distance formula is equal to, so here we're going to do y2, so negative 2, minus y1. We're doing A here, so y1 would be 0. Oops. Negative 2 minus 0 squared plus x2, so 0, minus x1, which is 8, squared. All right, so negative 2 minus 0, negative 2 squared is 4, negative 8 squared is 64. All right, so this is just going to be the square root of 68. All right, now this can be simplified. IB does not care. Okay, they do not care about simplifying fractions. They don't care about simplifying. The only time they do care about simplifying fractions, I take that back, is if it simplifies to a whole number, right? So like if you get 15 over 3, they expect you to simplify that to 5. But if you get 72 over, I don't know, 14, right? I mean, just anything that isn't going to be a perfect number, but does reduce, you don't have to reduce it. You can just leave it. Okay. Same thing with radicals. The square root of 68 would be perfectly sufficient. All right. E. The length of AM is 5. All right. Find the size of angle CMA. All right. So we have CMA. All right. I'm going to go ahead and just kind of complete this triangle here to make it easier visually. And that's obviously off. Let's see if I can doctor it up a little bit. Nope. Oh, well, let's just do that. Okay, so close enough, right? So now we know that the length of AM, they tell us that this is 5, right? And we just found CA, or AC, which is the square root of 68, all right? And we found MC, which is the square root of 41. All right, so this is side, side, side. So that's when we would use the law of cosines, okay? And the law of cosines essentially says that a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. All right, so we are trying to find CMA. So in this case, A can be A, C can be C, but M is going to take the place of B. Okay. Now you can rewrite this, right? We did it in geometry all the time, right? As long as this A and this A match up, and this B and this B and this C and this C, you can switch the letters around anytime you want. All right. So I can go ahead and find M squared is equal to A squared plus C squared minus 2AC times the cosine of M. And actually, I'm going to check your formula sheet just to see, because there's 2 forms of the law of cosines. And if they give you the second one, that's going to be really, really nice. All right, because that goes straight to the angle. All right, but I was assuming they did not. All right, so we will go ahead and check geometry. All right, so law. Yeah, they do give you sweet. They do give you both. Sweet. Okay. So, of course, you could just manipulate this, but we won't for the time being. We'll use the easy one. All right. And the one that they give you, right, is the cosine of angle C is equal to a squared plus b squared minus c squared over 2ab. All right. Of course, we're looking for angle M, which is really B, right? But again, as long as this C and this C match up, or this letter and this letter match up, and these two letters and these two letters match up, then you can change them around however you want, all right? So we can actually go ahead and say cosine of M, all right, is equal to a squared plus c squared minus m squared over 2ac. All right, so we'll go ahead and do that. All right, so we just simply plug in. We will do. Now, of course, what are we going to have to do once we plug all these in? We don't care about cosine m. We want just m. So what are we going to do there? How do we undo inverse cosine, right? So I'm just going to go ahead and jump straight to that. So I'm going to go ahead and say inverse cosine, all right, of, all right, and we said a squared plus c squared, all right, so the square root of 41 squared is just 41, all right, plus c squared, which would be 5, so 5 squared is 25, minus m squared, all right, m is the square root of 68, so m squared is 68, all right, over 2 times a times c, so a was the square root of 41, and c was, just 5. Whoops, I do want to go back and close that parentheses out. Close that parentheses out. All right, and we should get 91.78991061. Of course, you can write all of that, all right, or you can just do it to 3 sig figs, 91.8 degrees. All right, and now it wants the area of the triangle with vertices C, M, and A. Okay, so it gives us the area of a triangle, all right, which is A is equal to 1/2 AB times the sine of C. And again, you can actually rewrite this however you want, which we did in pre-cal as well, as long as all 3 letters are different, right? This could be AC, and this could be angle B. This could be BC, and this could be angle A. It doesn't really matter, all right? So basically, you're always doing the angle and the 2 sides that angle is between, right? So in this case, since we found CMA, right, we found this one. So I'm going to need to use the square root of 41 and 5, okay? So this is going to be 1/2 times the square root of 41 times 5, right, times the sine of 91.8. So we go ahead and plug that mess into our handy-dandy calculator. So 0.5 times the square root of 41 times 5 times the sine of 91.8. 15.9999. All right, so to 3 sig figs, 16.0. And you do actually need to put that 0.0 to make it 3 sig figs. Okay, so there was a lot going on there. None of it was really terribly difficult, and all of the formulas that you need are given to you in your formula packet. However, it's a lot, right? Like you kind of have to take your time thinking about all of that. And I think that's it. Any questions or concerns over number 4? Okay. Number 5. This one also looks a little messy. It looks like there's a lot going on here. All right, so an office tower in the shape of a cuboid with a square base, right? The roof of the tower is in a shape of a square-based right pyramid. The diagram shows the tower and its roof with dimensions indicated. The diagram is not drawn to scale. All right, so A, calculate correct to 3 significant figures the size of the angle between OF and FG. So OF is right here, FG is right here. Okay, so now we need to find, basically we want to look at this triangle, OFG. Does that make sense? Yes, no, maybe so? Okay. All right, so this is 10. Okay, so we're going to make triangle OFG here. So I'll call this OFG. All right, we know OG is 10. All right, what does OF have to be? 10. All right. All right, sweet. So now we need to find this angle here. All right, very good. All right, so we know that this is a square. Whoops. Okay. So we know that this is a square and this is a square, but they don't give us any of those values. Is that correct? Okay. And do they give that to us? Oh, okay. It's just weird. Oh, okay. Where do they give it to us? Did I just not copy it onto here correctly? Oh, okay. Oh, I got you. I got you. So I need to move it. There we go. Good call. Okay. So this is obviously 6. Okay. So again, we're going to use law of cosines, right? Because we have side, 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 right? So we can say the cosine of angle F is equal to O squared plus G squared minus F squared all over 2OG, right? So in this case, and of course we'll do the inverse cosine, right? So F is going to equal the inverse cosine of O squared would be 36 plus G squared would be 100 minus F squared also, which is 100 over 2 times O, which is 6, times G, which is 10. Of course, those would just cancel out. All right. So we are essentially doing some. Let's always do that to me. All right. So we will do the inverse cosine of 36 over 120. And we should get 72.5 to 3 sig figs. Now, when they tell you to 3 sig figs, which they did specifically, they would not accept the complete answer, right? If they specifically tell you, you have to write that. So in this case, 72.5. You're such a failure. They're sitting right up there. Yep. That's actually not 20. It's 2 times O times G. like 2 times side O times side G. Does that make sense? That definitely looks like a 20. I completely understand where you would think that. Does that make sense, though? I'm just using the law of cosines formula, but instead of using A, B, and C, since we had triangle like, you know, F, O, and G, I just kind of replaced those letters in there. All right, so because I have such little room to work, this is, right? This is going to be my work area, and then once we get that solution, I'm just going to erase it all, okay? So hopefully everybody has this in. Okay, so now part 2 says the shortest distance from O to FG, all right? Oh, I should have used that same triangle. Well, the shortest distance is always going to be a perpendicular to FG, all right? So we kind of have that same triangle. Let's just steal a triangle. All right, so we have that same triangle. So if this is O, F, and G, all right, then the shortest distance is always a perpendicular. So it's going to be like here. I know that's a little off, but we'll have to, come on, son of a biscuit. I don't think it'll get up right in the middle. Okay, no, whatever. It's close enough. You guys know what I mean. All right, so we need to find this, and we already, of course, said that this was 10, this was 10, this was 6. Now, because this is a perpendicular bisector, it actually does split this in half. So this would be 3 and 3. All right, and then we also found angle OFG, right, which was 72.5. All right, so now, actually, we didn't even need that. We didn't even need to know that this was 3 either. If we knew that it was 3, then we could use the Pythagorean theorem. All right, if we didn't know that it was 3, that it split it in half, we could just use what we just found, which I'm sure was their intent. All right, so I'll just go ahead and do that instead of using some geometric properties that many of us may not remember from geometry. All right, but now we can just look at this right triangle over here. All right, so, and we can use SOHCAHTOA, right? We want to know this here, right, which is from this angle, that is the opposite side, and I know my hypotenuse, so I'm going to be using sine. All right, so sine of 72.5 is equal to opposite, which I'll just call h since it's the height of that triangle, over over hypotenuse, which is 10. So h is going to equal 10 times the sine of 72.5 degrees. So we use our handy dandy calculator here. And we say 10 times the sine of 72.5 degrees. Right, and we get 9.53, all of that. So to 3 sig figs, 9.54. So this is 9.54 meters. Everybody okay with that one? Okay. Part 3 says the total surface area of the 4 triangular sections of the roof. Okay. So again, we're actually going to keep this same triangle, all right? So I'm only going to erase this stuff down here. All right, of course, I won't need this anymore. You could use it if you wanted, but don't need it. All right, so first we want to find, and this, of course, was 6. All right, we can use the formula for the area of a triangle, which they gave us, which basically the area is equal to the product of the two sides times the sine of the area included between those two sides. So the area of this triangle is going to equal 6 times 10 times the sine of 72.5 degrees. All right. So we go ahead and do that in our handy dandy calculator. And we get 57.223, all of that. Now, all right, because this is a right pyramid with a square base, all of these faces are the same. All right. Well, how many of these rectangular faces do we have? 4. So you just multiply that number by 4. All right. And we will get, and to 3 sig figs, that's just 229. And that would be meters squared. Right. So now they want the size of the angle between the slant height of the roof and the plane. What does it say? Probably EFG, maybe? Okay, EFGH. Gotcha. Bottom of the pyramid. Sweet. Okay. So now we want to kind of look at between the slant height. Okay. So what are we looking at here? Basically, we kind of want to think of a perpendicular here and think of this triangle, right? So think of having a point right here in the very middle of this, right? What do we want to call that point? Just pick a letter that we haven't used yet. Z. Perfect. All right. So think of that as Z. And then think if you come over to this, like the very middle of this, all right, and then you come up to O, this will be a right triangle. I know that that's hard to see in there, all right? So we'll go ahead and draw a separate triangle over here. Won't let me flip it. Okay. All right. So this here, right? Obviously O is up at the top, Z is down at the bottom, right? And then this would be a point which we essentially just found the distance of, right? Let's call that Y. All right, and we just found this distance, all right? Again, because this is a square pyramid, all of these are the same. It doesn't really matter which one we're going to. All right, so the shortest distance from O to FG, so we actually found this slant here, all right, was 9.54 meters. All right, now we know that since this is a square base and this is 6 units long and this is only goes to the dead middle of it, how long is this side here? 3, yeah. All right, and we found, let's see, between OF and FG. So we also found, okay, nope, that doesn't matter. All right, so we know that this is a right angle, all right, and we are looking for the size of the angle between the slant height of the roof and the plane EFG. So we're looking for this angle here. All right. So of course now we have a right triangle. We can use SOHCAHTOA again, right? So from this angle, this is my adjacent, this is my hypotenuse. So I'm using cosine, right? So the cosine of y is equal to adjacent over hypotenuse. So to find y, we just take the inverse cosine of all of that. So inverse cosine of 3 divided by 9.54. And we get 71.7 degrees. 2, 3 sig figs. All right. And then the height of the tower from the base to O. Okay. So we know what this piece is here, right? We know that this is 40 meters. Right? So we know that this is 40 meters. So we really need to find this height right here. All right. So of course we've used all of this rounded stuff. It sucks using rounded numbers, but that's fine. We really can just use the Pythagorean theorem here, right? A squared plus b squared equals c squared. All right. So we could say a squared plus 3 squared, which is 9, is equal to 9.54 squared. All right, so we subtract 9 from both sides and then take the square root of both sides. All right, so we're going to get the square root of 9.54 squared minus 9, and that will be 9.06. All right, so now we take the 40 plus this 9.06 to get 49.06 meters. Right now they said to 3 sig figs, so this would be 49.1. Are we good there? All right. So the hardest thing about these problems is kind of finding, okay, which triangle am I using? What triangle do I have to create, all right, to find whatever piece it is that they're asking me? Okay, so now, this next part down here. All right, a parrot's nest is perched on point P on the edge of BF. Okay, so we've got some point P on this edge. A person at point A outside the building measures the angle of elevation to point P, right, to be 79 degrees. So we have up here, and we know that this is 79 degrees. All right. Find, correct to 3 significant figures, the height of the nest from the base of the tower. So basically we're looking for BP. Okay, so we're going to have this triangle here. That's perfectly fine. So we're going to have this triangle here, and we're trying to find BP, okay, which I'll just call the height. All right, so of course this is a right triangle, right? So we know that this is 6. We're looking for this. This is the opposite. This is the adjacent. So we're going to be using tangent, right? So the tangent of 79 degrees is equal to the opposite over the adjacent 6. We multiply both sides by 6. Right, so 6 times the tangent of 79 degrees. Right, and we get to 3 sig figs, 30.9 meters. Right, so 30.9 meters. Right, so lots of triangles going on there, right? And they're not all obvious. Some of them are obvious, some of them you have to create. Right, so, and that's kind of the name of the game with these types of problems. You will always have one of these types of problems on paper 1 or paper 2. Right, it just always happens. So do be mindful there. Okay, the following diagram shows a triangle ABC. AB is equal to 8 meters, and AC is equal to 14 meters. BC is equal to 18 meters. Right? And BAC is 110. So it puts everything on here. Right? So A, calculate the area of triangle ABC. Right? Well, for the area, again, we can just do 1/2 times, oh, and I think I forgot to do that in one of the previous problems. I forgot to put in 1/2, but times the side, all right, times this side, times the sine of the included angle, which in this case is 110 degrees. So we go ahead and plug that in our calculator. All right, so 0.5 times 14 times 8 times the sine of 110, and we get 52.6. And that would be meters squared. Right, and now it wants to find the size of essentially angle C. So it wants to find this, right? Well, since we have all three sides at an angle, we can just go ahead and use law of sines here, right? So we would say sine of 110 degrees over its opposite side, 18, is equal to sine of angle C, right, over its opposite side, 8. So we multiply both sides by 8, right? And then we have to take the inverse sine of all of that. All right, so we can do that in our calculator. All right, so inverse sine of 8 sine 110 divided by 18, 24.7 degrees. We like those problems, short and sweet, without 37 different parts. What's, yeah, absolutely. It's 8 all love. It's massive. Oh yeah, yeah. I think 9 is too, right? Yeah, oh no, 8 is just two slides full. That's right. 9 isn't bad. Okay. All right, so here we go. The diagram shows a cuboid, 22.5 centimeters by 40 centimeters by 30 centimeters, and they give us the picture here. Calculate the length of AC. All right, so AC creates this triangle here. Of course, this is a right angle, right? So if you want to draw a separate triangle, that can help, right? So here we would have A, B, C, all right? And we know that AB is 22.5, and this is 30. So all we have to do is A squared plus B squared equals C squared, right? So this will equal the square root of 22.5 squared plus 30 squared. All right, so we do that in our calculator. And the square root of 22.5 squared plus 30 squared. Boom. 37.5. Wow, that worked out nice. All right, so this is 37.5 centimeters. All right, and calculate the size of angle GAC. All right, so now we have GAC, right? So that's going to be a right angle also, right? And we just found this length here, right, AC, and we have this length here, right? So I'll just draw a separate. That was absolutely god awful. Thank you. I thought it was excellent. It's actually way harder to draw on this little. Yeah, it's really hard to draw on this pad compared to on the actual smartboard. I can draw way better on the actual smartboard. Okay. This isn't a touchscreen, so yeah. All right. So here we can call this. Obviously, this is C. This is G. This is A. We just found AC to be 37.5. We know CG is 40. We know this is a right angle. All right, and we're trying to find angle A here. Well, from A, this is my opposite, this is my adjacent, this is a right triangle. I can just use tangent, right? So the tangent of angle A is equal to 40 over 37.5. So just take the inverse tan of both sides. And we get 46.8 to 3 sig figs. Absolutely. Right? Mm-hmm. Absolutely. Yep. Yeah, they are. And you will have one of these on your paper at the end of the year, like 100%. Yeah. Cool beans. Beans are cool. All right. So let's go to Kristen's favorite problem. Abby, did you get the same answers both times? Well, then you're good. Did we already do this on a different? No, like there's extra problems. Oh, right. Well, right. Yeah, this one's annoying. So hopefully we have enough time to get through it before the class ends. All right. So the diagram below represents a stopwatch. This is a circle with center O inside a square of side 6 centimeters, also with center O. The stopwatch has a minute's hand and a second's hand. The second hand, with endpoint T, is shown in the diagram and has a radius of 2 centimeters. Right? When T is at point A, right, the shortest distance from T to the base of the square is P. Calculate the value of P. Okay, so we know that this radius, so from 0 to A, is 2. Right? Then we also know that from here to here, another radius would also be 2. All right, and so that takes up a total of 4. We know that the whole box is 6. And since they both have the same center, then this is exactly in the center of the square, which means this has to be 1 and this has to be 1. Does that make sense? So the distance of P is 2 plus 2 plus 1, which is just 5. Fair enough. Pretty straightforward there. All right. So in 10 seconds, all right, T moves from point A to point B. Right? The shortest distance from T to the base of the square is Q. Right? So first, calculate the size of angle AOB. Okay. So how can we do this here? It's actually really easy. Okay. They said that this is a stopwatch, right? So this essentially is a clock, right? Um, how many angles are in a complete circle? How many degrees? Like what's the angle? 360. Okay. Well, in 10 seconds, what number would I be on in the clock? If I start at noon, if I start at 12, right. If I start at 12 and I go to 2, that's 10 seconds, right? Yes, right? Each number is 5 seconds. All right. So all you have to do is set up kind of I would set up a ratio, right? I'd say, okay, well, 2 over 12 is equal to x over 360, right? Because if you go from 12 to 12, that's all the way around, that's 360. So I would just say 12x equals 720. So you divide by 12, and yes, that is indeed 60 degrees. Right? So now the distance of OD. All right, so we're looking for OD, which is right here. All right, so now I have, I think this is really easy. I think it just ends up being 1, but yeah. All right, so here we know that this is a right angle, right? We know that this angle we just found is 60, which means this has to be 30. We know that this radius is 2, right? And I'm trying to find this distance here, OD. All right, well, we can just use SOHCAHTOA. We can pick either of these angles, right? I'll just pick this one, right? So this would be adjacent over hypotenuse. So the cosine of 60 degrees is equal to x over 2. So you just multiply both sides by 2. And of course, the cosine of 60 is 1/2. So 2 times 1/2 is 1. So that's 1. All right. And so now the value of Q. Well, now we have 1 plus 2 plus 1, so that's 4. Good times? I mean, are you guys just absolutely loving it? Kristen is. Look at her. She can't contain her excitement.
So wait, I have one question about this.
Yes.
So,
37, 42, 116, 62.7, 93. Right. All right.
well, I got the answer.
So in another 10 seconds, T moves from point B to point C. When T is at point C, the shortest distance from T to the base of the square is R. Calculate the value of R. Okay, so now we're going from B to C, right? So now we're going here. Well, this is just going to be an identical triangle, right? That's this one right here. Yes, no, maybe so. Yeah, so this is just going to be 1, right? Which makes this 1. So R is just 1 plus 1, which is 2. Pretty straightforward. Yeah. Did it take you a little bit longer to get through that? Right. Right. Okay. So this is just a continuation, but I don't think we need the picture for the rest of this, so that's why I put it on another page. All right, so let D be the shortest distance from T to the base of the square when the second's hand has moved through an angle theta. The following table gives values of D and theta. All right, the graph representing this function is as follows. All right, did I miss something? Shouldn't it have asked me? Okay, there we go. Shouldn't it have asked me to find? Oh no, we have R and P and Q and all that from before, right? So who's looking at the page? What is P? 5. Q was 4. R was 2. So 2, 4, and 5. Okay. So the graph representing this information is as follows, right? The equation of this graph can be written in the form D equals C plus K cosine theta. right? Find the values of C and K. Okay, so what we're going to do here is we're going to use these points, all right? However, we need to use one point that is going to automatically eliminate this K, okay? So cosine of what equals 0? Think of the unit circle. No, sine of 0 is 0. Cosine of 90 will be 0. Okay. Think of cosine as the x coordinate on the unit circle, right? You're going, in order for your x coordinate to be 0, you have to go straight up, right? Which is essentially 90 degrees. All right, so I'm going to go ahead and plug 90 degrees in here. Well, when my theta is 90, I know my d is 3, right? So I can say, okay, d is equal to c plus k. I'm sorry, in my d, we already said it was 3. So 3 is equal to c plus k times the cosine of 90 degrees. And we know the cosine of 90 degrees is 0. And so, of course, k times 0 is just 0. So 3 is equal to c. Okay, so now I can pick any other point that I want. It doesn't really matter. All right, let's just pick another angle. A really easy one is 0, right? Because cosine of 0 is 1, right? So we can say, okay, well, d, oops, we know d. All right, so if I'm picking 0, then my d is 5, and that is equal to c, which is 3, plus k times the cosine of theta, which in this case is 0 degrees. All right, well, a cosine of 0 is just 1. So this is 5 is equal to 3 plus k. So subtract 3 from both sides. K is equal to 2. Done. Did that go faster, Kristen? Well, I kind of know what to look for, right? Okay, number 9. In this diagram below, ABEF, ABCD, and CDFE are all rectangles. AD is equal to 12, DC is equal to 20, and DF is equal to 5 centimeters. All right, M is the midpoint of EF. All right, and N is the midpoint of CD. Good times, good times. All right, A, calculate the length of AF. Okay, well, here we have 5, here we have 12. You can use a squared plus b squared equals c squared if you want. I know this is a 5, 12, 13 Pythagorean triple. So that's going to be 13 centimeters. You forgot about Pythagorean triples. Of course, if you do a squared plus b squared equals c squared, you'll get 13, right? This will be 144 plus 25, which is 169. The square root of 169 is 13. All right, the length of AM. All right, so now we're doing this triangle here. All right, well, we know these are rectangles, so I know this is a right angle here. So if you want to kind of redraw it, you certainly can. All right, so we have a right angle. All right, we just found that this is 13. Since this whole side is 20 and M is the midpoint, I know that this is 10. All right, so this would be a F N, right? And we want to find AM. We just do the Pythagorean theorem again, right? So a squared plus b squared equals c squared. So this is 169. This is 100. So add those and take the square root. So this would be the square root of 269. All right, that is exact. So you're allowed to write that. Of course, you could just say the square root of 269, and you could do that to 3 sig figs, and you could do 16.4. Okay, so you could say, or you could write the entire decimal, right? They would accept that as exact as well. All right. Is that it? Oh, no, here. B. Calculate the angle between AM and the face ABCD. Okay, so there's AM and the face ABCD. Okay, so essentially, what are we going to do here? We're going to connect this and then make that triangle. Okay, so the easiest way to do that is essentially, right, so we're going to have, this is going to be M and N, and this would be A, so this, they should actually be switched. So M, N, and A. All right, we know AM is the square root of 269. All right, we know MN, since this is 5, this has to be 5 also. All right, and ABCD, AN is on ABCD, right? So AM and AN, we're looking for this angle here. Right. And we can just use SOHCAHTOA since this is a right triangle. So we can just say, I don't know if it's on. So here this is opposite, this is adjacent, so we're using tangent. So the tangent of angle A is equal to the opposite, which is 5, over the adjacent, which is root 269. So we take the inverse tangent of that to get A. Uh, 5 over root 269. Bam. 16.95, or to 3 sig figs, 17.0 degrees. Yes. Okay, so we finished it. We made it through. Yay us. All right. Any questions or concerns?
So you can't give me the answers?
I cannot give you the answers.
I mean, will you really lose your job if you do though? Like.